Hello everybody, in this video I will discuss trigonometry in the first quadrant. Here we will use a diagram to determine the value of trigonometric ratios. No calculators will be used. You only need the theorem of Pythagoras and the three trig ratios. Now what's given here is the Cartesian plane, the four quadrants, and O is at the origin. Then when I'm giving you angle alpha in standard position, there is a ray and it ends in a point, and your point is P, and it consists of a coordinate, a x and a y coordinate. And then from that point P, you can drop an altitude. And an altitude is perpendicular to the x-axis. And you see that now suddenly there is a right angle triangle. So in your right angle triangle, this distance from the origin up to this point, the length is x. And then also from the axis, the x-axis there, up to that point, that whole distance is the y coordinate. And then from the origin up to point P, the ray is also your radius. And then you find a right angled triangle in the first quadrant. Now the question is, use the diagram to determine the value of the following without a calculator. And what we are looking for is sin alpha and tan alpha. Now, in fact, when we want sin alpha, sin's ratio, right in the beginning in lesson 1, I said sin's ratio is opposite over hypotenuse. But I also said sin can be y over r, and that is what we are working out here. We are working with the x and y coordinate as well as r. Now when you go to your sketch, you will see that your right angle triangle is in the first quadrant. And there is a coordinate, and remember, a coordinate consists of an x and a y. So that means there's also r. From the origin up to the point, you find your radius r. Now, that coordinate gives x value 4 and y's value is 3. So what we are looking for is the missing side's length, and in this case it's r. Now we are going to use the theorem of Pythagoras. R squared is equal to x squared plus y squared, and you have to add Pythag there, and then we are going to find the missing side, and as I said, in this case it's r. Now we're going to substitute this coordinate that was given, the 4 and the 3. So into x's place we substitute 4, and into y's place we substitute 3. Then r squared is equal to 4 squared is 16 plus and 3 squared is 9. Then r squared is equal to 16 plus 9 is 25. We don't want r squared, we want r. Therefore, we will take the square root both sides. Remember, when you take the square root on the right hand side, you have to add plus minus. Therefore, r is plus or minus 5. Now, the rule in maths is r is always positive. So in this case, you will choose the positive number for r. Therefore, r is 5. So now you will see you have all three, the x, the y, and the r. Now we can go to the sum. And the sum was find the value of sin alpha. Then since ratio is opposite over hypotenuse, but here you rather write since ratio is y over r, and then the y value was 3 and we calculated r was 5, and that's the answer. B, they want tan alpha. Then you say tan's ratio is opposite over adjacent. Let's go for y over x, and then the y is 3 and the x is 4. So the answer 3 over 4. Let's do another example. Use the diagram to determine the value of sin alpha over cos alpha without a calculator. And then there's your sketch, your diagram, and it's in the first quadrant. And what's given is that your r is 13, so the radius is 13, and then x we don't know, that's the one that we're going to calculate, and r is given that it's 5. And then our alpha is in standard position and we find a right angle triangle. Therefore, we're going to calculate the missing side, the x, with the theorem of Pythagoras. Now we are going to substitute. So in r's place, we will substitute 13 squared equals, and x is the one we're looking for, plus, and then this coordinate was the y coordinate. So into y's place, we substitute 5. Then we say 13 squared is 169 equals x squared plus, and 5 squared is 25. Now we're going to solve x. Therefore, 169 minus 25 is x squared. 169 minus 25 is 144, is equal to x squared. But I don't want x squared, I want x. Therefore, I will take the square root both sides. Remember, when you take the square root on the number, you have to add plus or minus. In that case, plus or minus 12 is equal to x. Now, since you have two answers there, the one that is the correct one for this sketch is x is plus 12. Since your triangle is in the first quadrant, x and y both are positive in the first quadrant. Therefore, x is 12. Now you have x, y, and r's values, and you can do your sum. So the question was, find the value for sin alpha over cos alpha. Sin's ratio is y over r, divide, and cos's ratio is x over r. Now we substitute. In y's place, 5 over r is 13, divide by x is 12, we calculated that one, over 13. And then remember, we don't divide in maths, we times. So and then when you turn this into a times, then this will swap around. Therefore, it's 5 over 13 times 13 over 12. And then 13 and 13 will cancel, and you're left with 5 over 12. Use the diagram to determine the value of 2 cos alpha minus 1 without a calculator. Then there's your diagram. In the first quadrant, r's value is root 2, x is unknown, and y's value is 1. So we will be calculating x, the value of x, with the theorem of Pythagoras. So we start with r squared is equal to x squared plus y squared, Pythagoras. Now we're going to substitute into the theorem of Pythagoras. R's value is root 2, inside a bracket squared, equals, and x squared is what we're looking for, plus, and y's value is 1 squared. Then we can say root 2 squared is just 2 equals x squared plus, and 1 squared is square. 1 squared is 1. Now I'm going to solve x. Therefore, 2 minus 1 is x squared. 2 minus 1 is 1 is equal to x squared. But I want x, not x squared. Therefore, I take the square root. Remember, when you take the square root, you add plus or minus. Therefore, x is plus or minus 1. Then, since our triangle is in the first quadrant, the x we're going to choose is the positive one. X is therefore positive 1. Now that we have all three values, the x, the y, and the r, we can go to our sum. 2 cos alpha minus 1. Then it's 2 bracket. Cos's ratio is x over r minus 1. And then now we can substitute. In x's place we substitute 1. We calculated that one. And r was given root 2. And then all you can do is you can multiply this 2 in with the 1. And you end with 2 over root 2 minus 1. And you stop there. Let's do another one. Use the diagram to determine the value tan alpha times cos squared alpha without a calculator. And then what's given was a right angled triangle in the first quadrant, and given is r is 10, x is 6, and the y coordinate is missing. That's the one we are going to calculate with the Theorem of Pythagoras. Then r squared is equal to x squared plus y squared. In x's place we will substitute the 6, and in r's place we will substitute 10. Therefore it's 10 squared equals 6 squared plus y squared. 10 squared is 100 equals 6 squared is 36 plus y squared. Now we're going to solve y. Therefore 100 minus 36 is equal to y squared. 100 minus 36 is 64 is equal to y squared. We don't want y squared, we want y. Therefore, we take the square root both sides. When I take the square root on the number, I add plus minus. Therefore, the square root of 64 is plus or minus 8 is equal to y. Which one to choose? We take the positive 8. Why? Because in the first quadrant, x and y are positive. Therefore, y is positive 8. Now back to the sum. Tan alpha times cos squared alpha. Tan's ratio is y over x times cos's ratio is x over r squared. And can you see I put a big bracket around this x over r since it's squared. Now I substitute. Y is 8 over x is 6 times x is 6 over 10 in a big bracket squared. Then I say 6 squared is 36 over 10 squared is 100. And now I can say 6 goes in itself once, 6 goes into 36 6 times. And then what's left is 8 times 6 is 48 over 100. In the next video, I will discuss special angles in trigonometry. Click on the video in the left-hand corner to take you straight to the next lesson.